A question about the size of the C10 archive. You mentioned what, 40 gigabytes or whatever. But when I think of a TeX distribution, I think mostly of the class files and things like that, which are relatively small text files. So even if there are 5,000 of them, that's orders of magnitude smaller. So what really makes it so big? Is it fonts or?
It's really lots of different things. Again, the figures were 16,000 plus directories and 290,000 files. So there are TeX files, there's documentation files, there are PDF files, there are figures and tables and images inside the PDF files. And it just grows and grows and grows. And it's also important to remember that CTAN itself doesn't really contain executable programs. That's what happens in TeXLive in the bin subdirectory. But as the amount of material people contribute grows, the archives grow too, and it doesn't seem there's any end to it. Now, one, of course, can use text compression, and there are already file systems that natively compress on disk so that things take a lot less space. And with repetitive log files, there are compression algorithms that will give you 100-to-1 compression. For more general files like a TeX or LaTeX style file, probably a factor of 3 to 5 is what you could gain by compression. But even then, that would only knock 44 gigabytes down to perhaps 10 gigabytes. And that's still too much for people with a 1 kilobit, or not a kilobit, but say a 20 or 50 kilobit link. It just moves stuff.
I'd like to give a different and perhaps slightly mischievous answer to this problem. Of course, an archive shouldn't throw things away, and certainly shouldn't throw things away without good reason. That's the point about an archive. And so archives get bigger and bigger and bigger. We traditionally think of libraries as being archives of sorts. But nowadays, if you say to a library, because it's happened to me, I've got these maths books that are quite good that I don't need anymore. That's not me, a friend of mine had that problem. Would the library accept them? And you find that libraries won't accept free books, even though they're quite good books, because, well, in some sense, they've got enough books already, and also because they've shifted over to a very great deal to electronic media. So whilst from one point of view, more is better from an archive, from another point of view, it's a bit of a nuisance. I'll now be a bit mischievous. First of all, let me say that my first PC had a 40 megabyte hard disk, and I could run TeX on it. I could also multitask MS-DOS on it, and I had 2 megabytes of memory. And it was adequate for purposes. So for limited purposes, a small version of TeX will work. The mischievous thing is Pascal's apology. He wrote somebody a long letter, and at the end of it, he said, "I'm sorry that I've sent you a long letter. I didn't have time to write a short one." That actually writing a short letter takes much more time than writing a long letter. The same thing often goes for writing a proof, a mathematical proof. Jim and I both use a language called Elm, which works on the web browser. Now, the web browser is a rather funny environment because whilst a certain amount of caching is possible, in principle, the software is then downloaded along with the page. So the size of the download is really important. How much material do we have to send down the internet connection? And it might be actually a mobile phone that is the target device through a 4G network or something like that. So there, compression of all sorts is very important. And there are people that have written very clever tools for compressing JavaScript and so forth. Now, Elm, because of the way it's designed, because it's a functional language, you can write a big program or write a program that calls upon hundreds and hundreds of libraries. And because Elm knows exactly what is and isn't used, it can remove pretty much any piece of code, in practice, all pieces of code or most pieces of code that are not used. So you ship only the things you need for the page. And to go back to a story with Don Knuth, one of the things you can do when you're testing software is to check that your tests execute every line of code in the software. Have you tested every line? It's coverage test. He found that a piece of software he was writing, he couldn't test. His tests were missing this one line of code. After a bit, he proved that that line of code couldn't be executed, and so he deleted it. That's one way of getting 100% coverage for your tests. So I think there's a similar sort of thing going on regarding CTAN. The archive should store everything so that it's like if you have a car and the car is still, so to speak, under maintenance, you ought to be able to get a spare part for every part of that car. Every part of that car, you ought to be able to get a spare part for it. And when the car is, the same goes for a washing machine and other things. And when it goes out of maintenance, all these spare parts become unavailable. And if you want to put a new engine into your 55 Chevy, you can, because you get them remanufactured by third parties. But finding spare parts for classic cars is a difficulty. And an archive for software allows classic software to be run. And we can run tech like it was 1985 if we wanted to. So whether or not the archive being big or small is a sort of, it depends. And from the point of view of storing everything, it should be good. But I think it's really important to say, what's a sensible subset of tech? And for reproducible software, the smaller reproducible documents, in some sense, the smaller the better, because then you can say, oh, somebody has changed this piece of software that's part of the archive, but I don't use it, so it won't affect my document. So I don't have to test that my document still runs correctly, because none of the inputs have changed. So I think a very useful middle ground would be to take existing documents and say, well, what are their dependencies? What do they actually depend on? And can we package that up so that we don't need, so somebody can start quickly? And if we can do that effectively, then something very interesting happens, which is you can run tech in the web browser. In fact, you can run Linux and X Windows in the web browser. And I came across something called Tech, which I might have seen before by accident. And it will typeset using JavaScript in the web browser, KERTEX, will typeset JavaScript in the, typeset a minimal document using plain text in the web browser, running Linux in 0.2 of a second. That's without doing any sort of optimizations. It's sort of Linux is being run as Linux and tech is being run as tech, and there's no optimizations, like 0.2 of a second. So probably now on a decent machine, my machine isn't that decent. It's, you know, sort of 6 or 7 years old in terms of a CPU. Probably now on a decent machine, you could typeset a paragraph in 1/10 of a second. You could typeset a page in 0.3 of a second using something that's downloaded onto the web browser. So having a minimal distribution of tech, for example, that will support Beamer, would allow somebody to say, oh, I want to write a Beamer slide. I can do it in my browser. And that will be, we hope, a sufficiently pleasant experience that even if it's a bit slow, and it might not be a bit slow, they'll be encouraged to go forward. So I see minimal versions of tech running in the web browser. And remember that I started with a 10 megahertz machine, an AT, with 40 megabytes of memory and 2 megabytes of RAM. And that was my initial experience with tech, and it was satisfactory for me, although it took a second to produce a page or something like that. So having that sort of experience, whether you do it through a remote server or through JavaScript in the browser, is, I think, very important. And even if you do it in a remote server, even though storage is, so to speak, cheap on a server, cheap, quick storage is expensive on a server, even today. And many of the devices today have SD-RAM or something equivalent. The machine I'm talking to you on is a Chromebook, and it has, I think, 16 gigabytes of a rough equivalent to a solid state disk, of which about 8 is used by the operating system. So even today, with gigabytes of memory being cheap, people have sort of memory limited devices. So I think we need to have a sort of bifurcation of, here's the archival tech, and it really is archival, and we want it to be really archival. And here's the stuff that's busy, and we want it to be small. So we want to have electric scooters, and we want to have interstate commerce trucks. It's that sort of range for the archiving and so forth. So both lightweight and large scale. So I'll stop that, because that's a different take on things, and it's sort of looking forward a little bit to what happens in the future.
I'll just toss in a note here that for a number of years, I kept a log of the times it took to typeset the tech book. This is the version you're not supposed to typeset, but we only use it for benchmarking, so I figure that's all right. And it doesn't have the lovely Dwayne Bibby drawings in it that begin each chapter, but it's the text of the full tech book with all of the difficult mathematics in it. And when we started doing this, probably back in the early 90s, we would get speeds of tens of pages per second. And when I stopped doing this a few years ago, we'd reached about 1,500 pages a second. So in other words, a technical book, if it doesn't have complicated figures and images in it, can be typeset in less than a millisecond on desktop processors that people are routinely buying. And that's really encouraging. The problem, of course, is that pretty soon people want images, and they want PDF files embedded in their documents. And those have sizes and contents over which we have no control, and they get big fast. And so even though a book, as say a detective novel, is roughly a megabyte, in other words, if you take 300 pages and 50 lines of 60 characters, that's about 1 million characters. But if you actually look at PDF files for real technical books, they're 10 to 50 times larger than that per page. And the reason predominantly is figures and tables with images, and also fonts, because PDF files normally will contain fonts. Because even though there's a default set of fonts that all PDF readers are supposed to have available, in practice, you can't necessarily rely on that. And as we move into the realm of Unicode fonts with potentially 100,000 characters, those resources become quite large. It's an interesting exercise, in fact, to take your favorite document that you've been typesetting to get a DVI file with plain tech or LaTeX, and just run it through LuaTeX or LuaLaTeX or XeTeX or XeLaTeX, which are the Unicode engines. And you'll discover that it runs several times slower. It is not anywhere near as fast. And the difficulty, of course, is that the Unicode font repertoire is much larger and much more complicated. It just takes time to get things going and to get stuff loaded into memory.
I think there might be a topic for further discussion here.